using the free download Deep View. The next area I'm going to cover is how to create animations within Deep Exploration. This panel on the right hand side called Steps and Procedures deals with animations. Now I've already created some short steps here that show the assembly process of this product for use in a factory or assembly environment. Animations can be a very important tool for designers. They can be used to clarify and validate how mechanical designs work, or they can be used for marketing, or as we can see here, manufacturing or assembly purposes. These animations that I just played are just a set of short, simple sequences that you can see listed here. If I activate one of these sequences and move the animation slider at the bottom of the screen, you can see the movement involved in that sequence. These sequences are really very simple to create, and I will show you an example of creating a sequence and then how to group these sequences together to create a longer, more detailed animation. With this product, the sub-assembly on the right hand side of the screen with the green casing needs to be lifted and assembled onto the other casing. So I can just create a new sequence here on the right hand side, then go and give it a logical name, and I can specify the length of this sequence, so in this case I'll choose to make it 2 seconds long. So now all I have to do is simply record what I'm doing on the screen. I'll just slide the animation slider to 1/3 across and then hit record. So here I'll select the sub-assembly and then go to my animations tab at the top, and we'll just move this sub-assembly up from the ground plane. And then we want to rotate it 180 degrees, so I'll select the rotate tool, and we can see how many degrees I've turned it up in the top right hand corner there. And all I'll do then is stop recording and move the slider to 2/3 across, and then record the next bit, which is moving it across to the other casing. I can switch views at any time to get a better look at what I'm doing, and then once it's in position, like so, I'll stop recording for the final bit. So I'll move the slider to its final position, start recording, and then we need to bring the casing down to its final position. So just make sure that's in its correct position, and that's finished. So now I can play that new sequence from beginning to end, or I can simply use the slider to slide it back and forth like so. I can just reorder these sequences by dragging and dropping them. It's not required to have them in the correct order, but it does make things more logical to look at. I'll then go back to the Steps and Procedures tab, and I can group these short, simple sequences together to make a more detailed animation. I'll create a new step and give it a name, and I can add some assembly instructions to come up on the screen when this step is playing. I could also annotate these animations with symbols or logos, for example, arrows further indicating where a component is placed or highlighting areas where common mistakes can be made. I'll then simply add the sequences I want to feature in the step, and at this point I can also reorder them if I want. Then we can also say here that whatever orientation the product is in when I play this animation, it should take 2 seconds to fly to the view of my choice, and this is something that makes the animation look really nice when it transitions from one step to another. So once that's done, I'll just update the position in which this step is viewed, and to do this I'll just run the previous step, and then reorientate just to get a better view of the detail and what's happening in this final assembly step, like so. And then I can play all of these steps together. Firstly, we can see the layout that the person assembling this product should have on their assembly desk, and then the final assembly process. And we can see here the transition between steps taking 2 seconds to fly to that new position that we specified. So as I mentioned before, this could be used by many different departments within a company to educate people or show people how designs work, or how they are assembled or disassembled, or quite simply to convey conceptual designs to other designers. And at any point the viewer can stop the animation and go and interrogate the model to look at certain areas in even more detail. These animations are also viewable in the free to download application Deep View, which we saw earlier on when we were looking at markups. So finally, this set of steps could be output and saved as a fully rendered photorealistic file, the most common of which would probably be the AVI format. So that's a quick overview of animations and how they can be created and viewed. next area I'm going to cover is how you can create photorealistic renderings within Deep Exploration. I'll go to my rendering tab at the top here, so I have access to all the relevant toolbars. Now if I hide this top casing, we can see there are lots of internal components which wouldn't be seen in a rendering and use up valuable processing power when creating renderings. There is a specific tool here to remove internal components. So if I activate that tool and process the data and then hide the top casing, then we can see those internal components are gone, and this will improve our rendering time later on. Deep Exploration comes with a library of high dynamic range materials that you can see here, and to apply these materials, it's as simple as dragging and dropping them onto the components. So I'll add some materials to this product to make it look more realistic than the standard CAD colours that came when this file was imported. So a gloss black there for the main upper and lower casings, and a beige plastic for the side casings, and we can just add a rubber material for those feet. These materials are extremely detailed files and contain a huge amount of data. We can see here, if we look at the properties of this gloss black, the type of materials it is, the type of finish we can choose, and here we can see different maps can be specified. For example, a 3D texture could be specified as a bump map. And further detail can be applied to the part regarding materials. We can UV map these materials onto different parts. If we look at the properties of this switch, we can see how the system can unwrap that part into 2D, so it can more accurately calculate the light reflections on that component. So once that's done, we can change the rendering engine used in the viewport. This menu in the bottom corner shows the ones available, and I'm going to switch to the High Dynamic Range real-time driver. High Dynamic Range is basically a set of techniques which allow the computer to more accurately calculate light definition, and it's this light definition that ultimately is going to give our image its photorealistic quality. Now with the High Dynamic Range renderer comes something called environment maps, and environment maps are basically 360-degree high definition images with lights built into those images, and to use these you simply drag and drop them into the scene. So here we can see an example of an environment map, this lawn scene. It's not really suitable for this product, but straight away you can see it makes those materials much more realistic. So for this rendering we'll choose one of the many studio environments that's available in the Deep Exploration library. And I'll just simply orientate this product into a position we want for the rendering, like so. And then we can take a quick look at the rendering properties. So here we can see all the different preset sizes you can choose, and you can specify things like resolution. And we can see here there's a slider for the overall quality of the image. Now I've left this on a fairly low image size and resolution and picked a draft quality so that it renders quite quickly. But later on I'll show you some images of this product where the settings and resolutions were ramped right up. I've just selected the render icon, and this should take a few seconds to render this image. So that's our final image there. And for a quick draft image, it's really of a very good quality. You can see the depth in the plastic on the sides, and the reflection in the paint on the top is particularly good. And it's these high gloss and metallic materials that are notoriously difficult to render in other rendering packages.